Hey, and welcome back. First, I want to thank you guys for the response in my recent videos. It's been very nice to see all that support. Okay, so let's see what we're gonna do in this video. I thought to talk about some of the HackerOne reports because you guys like the explanation. So I thought to pick some of the random reports from Hacktivity yesterday and thought to talk about this. Okay, so the first one is LinkedIn broken link hijacking. I'm going to talk about some low-level plus some high-level reports, so it's gonna be a mix of everything, whatever I saw in the activity first. So this one is a pretty simple one. Broken link hijacking happens when there is a link that the web application is using, but that link is actually invalid and it is giving 404. So in this case, the user had a profile in this web application, a LinkedIn profile, but the link of that LinkedIn profile is not working anymore, probably because that user is not using that LinkedIn anymore or deleted the account. But that link is still embedded in the source code in this particular web application here. In that case, you can perform broken link hijacking by simply using that link to post your own content. But let's have a look at this POC. I'm going to reduce the volume. Okay, so you can see this person, Gabriel, has this LinkedIn profile, but this link was probably giving 404, so this user has changed it and he posted his own account here. So anyone who click on that link from the web application will be redirected to this particular LinkedIn page, which is not legit and is attacker control. So in that case, the attacker can impersonate that user and do other things. The severity of this vulnerability in this case is low, but it can also increase to medium depending on the situation. So that was a nice small report over here. Let's move on to the second one. Moving on to the second report that is reported to US Department of Defense, the title goes improper authentication allows making appeals on other users. Let's see what's this about. This vulnerability allows unauthenticated users to submit manipulating HTTP responses by tuning server responses from a redirect to successful response 200. Attackers can bypass the application authentication requirements and perform actions reserved for logged-in users. Let's look at the steps to reproduce. First, capture a GET request to endpoint app/createapl.aspx, and then forward the request to intercept the server response. After intercepting the response, change the response code from 302 to 200 and forward the modified request to the browser. From this point, fill the required fields, intercepting and modifying the response for several of the drop-down selections as well in order to be able to proceed. For the email field, we are able to input the email address of another application. Okay, so basically what's happening here is there is a form that users who are not authenticated are not allowed to access, but this can be bypassed if you just change the response from 302 to 200 by using Burp Suite. And then you will be able to see the form, and then you can fill the form, submit the form, and then again you can simply do response manipulation to successfully use the endpoint even though you are not authenticated. In this case, there is another endpoint that takes a parameter, email, and this is the email address. And after applying an email and filling the required fields, submit the request. As a result, an email will be sent to the victim email address verifying successful submission. Okay, so this is something you should all look for. Actually, I've seen multiple cases of response manipulation. You can try this out in multiple scenarios, not in just creating an account. In this case, you can also try it in password reset or trying to update something that you're not allowed to do. So for example, if there are multiple roles, and if you can create something that only admins are allowed to do just by using response manipulation. So this one is a good, and this goes with the severity of medium. That's nice. And here is the mitigation. Because there is only client-side validation, not server-side validation, so by manipulating the response, the client believes, okay, this is the legit response from the server, and it allows you to access things that you are not allowed to. Moving on to the next report, we have this IDOR/back vulnerability on custom Apex controller. So this one is reported to US Department of Defense, that is developed by Salesforce itself. It's called Apex, and Apex is used to add custom logic to the Salesforce instances. You will see once you look at all these requests, it's a bit weird one, but this is their syntax for the Aura framework. And we will break that down as well. So, Apex has different classes and methods, and Apex classes can be run in two modes. The first one is with sharing, and the second one is without sharing. So in with sharing, the Apex code respects users' record level permission but still ignore object level and field level permissions. If it sounds a bit complicated to you, then in simple words, it basically keeps the permission in checks and checks which user are allowed to access what object. But if there is without sharing mode enabled, then any user is given unrestricted data access and modification, and this increases the risk of IDOR or back vulnerabilities or SQL injection as well. But in this report, we have the IDOR, so we are going to focus on that one. As you can see, this block mentions the IDOR vulnerability here as well that allows users to read or even exfiltrate full tables of data that they should not be able to access, and this could also lead to data integrity issues. So this vulnerability is basically about abusing Apex classes which are not set up in a proper way, and that's why this vulnerability is reported to this US Department of Defense and not the Salesforce, because it depends on the businesses and the clients how they are implementing it. So it is, you can say, an implementation issues, and they didn't check how the Apex classes were being used. Back to this blog, we can see we have this request here and the response as well. In this case, the controller is different and the method is different, but this is how the request and response look like. If you want to, you can check out this blog as well, but our main focus is the report right now. So let's have a look at the steps so we can figure out what's actually going on here. The first three steps basically talk about creating an account and verifying the account using the link received in the email, and then changing the password and logging into a particular portal. There you will receive aura.token. Aura.token is basically JWT token, which you will see in the request like this. I'm going to decode this whole URL encoded message. And let me zoom this out. Okay, now this looks a bit more clear. So first we have this message here that contains action, which is an array, and it contains multiple key value pairs like ID, which is the action identifier, and then the descriptor that contains the controller name and could be a class name as well, and then the method name that is a calling descriptor. And then we have some other parameters like version, app, loaded, and page URL where we are requesting it, and the token. So the main things that you have to keep in mind is the descriptor value that contains the type of action being called, and the other IDs which we will see in the further requests. But this is how the basic request looks like. Okay, moving on to the fourth step, it says send the request to repeater and modify as below and send. This will pull some info from your own contact record. Save the contact ID. Okay, so we have this particular request here. Let me copy this as well. Paste and then decode. In this case, we can see the ID here is different because a different type of action is being called here. This time the action is this, and it seems to be fetching something. As you can see, get items. And sorry for messing up. The previous one that I was calling method, calling descriptor, is not the method. The method is actually after the $sign. So in the previous case, the method must be this one, get component attributes. Okay. And then we have the FWUID, which is basically the session ID of the user. And then we have the page size, which tells how many records the user wants to fetch. In short, this simple request is basically loading attributes related to a particular session. But again, this is also not very of importance here. There is nothing related to either here. We're just trying to understand the request here. Going back, the hacker says that if you send this particular request, it will give you your own contact record. And that contact record will contain a particular ID. In the case of this hacker, the ID is this. So assuming we got this ID, we can move on to the next step. Let's copy this body message, decode, and here we have, okay, seems like I copied the same request. My bad. The next one is actually this one. Yeah, we can see this time the ID is different because a different action is being performed here. And this is the third request. In this case, we have an Apex class called file upload controller, and the method name is clone attachment. As the name suggests, we are trying to clone a document or an attachment. Okay, then we have two parameters. So a particular action can have parameters as well. And in this case, we have two parameters, that is attachment ID and parent ID. Attachment ID contains a random value of the attachment, and the parent ID is the ID of the owner who's trying to perform some kind of clone action. The thing is, from the previous request, we got a contact ID. You can use that contact ID in the parent ID here, which seems to be the same thing or could be doing the same thing as an identifier of the owner. Or you can also call it the parent record ID. Okay, so this particular request is trying to perform a clone action. And what it's going to do is going to attach this particular document to this particular owner. To give you a bit context, this is your own ID that you will receive from the previous request, but this is something we didn't fetch actually. This is what the hacker provided in the report, so it could be easy for the triager to validate this. But if you want to enumerate these IDs, there is a way to do it, which I think the reporter has mentioned. Yeah, this particular blog. As you can see, this says identifying a Salesforce app and Salesforce ID. Salesforce ID seems to be random like this, but they still can be enumerated. If I go down a bit, you can see that all these IDs are same, but in the end we have the particular letter P and M. So if the ID starts with PM, P will be same, and then it will move on in alphabetical order, that is M, N, O, and then up to Z and X, Y, Z, as you can see here. And then it will switch to Q and then start from 0 and then again to Z. So this is not really random and it can be enumerated. So this person has created a Salesforce ID generator a Python script, and this script can be used to enumerate IDs. So if you want to, you can try this out. For making things easier for the triager, the reporter has mentioned the particular attachment ID in the report itself, which is this. Okay, moving on to the next step, which is this one. Modify request again and send, this time calling all accessible attachment records. Note that the new file has just been cloned, created, and the copy ID is this. Okay, so when you clone a copy of an attachment, you get a particular copy ID as well. Again, let's copy this message. URL decode. And we have a different ID and a descriptor value, which is basically fetching the items. As we can see, it says get items, and it's fetching the attachment, and it wants the total number of 2000 records. And the session ID is still same, and the aura.token is still same, but you are trying to fetch a record that you just cloned that belonged to another user. Back to the report, insert the ID into the URL, same session, and verify that the file is accessible from your account, basically an IDOR. So this particular URL is the bug URL, you can say, and this file parameter is vulnerable to IDOR, in which you can fetch the ID of the cloned attachment. I hope it is making more sense now, like how these things are working here, moving forward step by step, and how we were able to fetch the ID. In a real case scenario, an attacker would first try to fetch the IDs using that Salesforce script I showed you, maybe, because the IDs are actually in alphabetical order in the end. And then the attacker can try to craft a request like this to first clone the attachment using this particular method, that is clone attachment, and then try to fetch the attachment using the get items, and then try to access each attachment using this particular URL. So because of the broken access control, an attacker can clone as many attachments as they want and see the details in them as well. And it is very critical, hence we have this severity. Next up, we have this WordPress vulnerability, which might look pretty simple, but it is of critical severity. So it is reported to Autodesk, and there is a particular WordPress endpoint that is enabled, and it gives the attacker too many usernames and emails that looks like this. As you can see over here, zoom out. So these are the URLs, and these URLs have this author, and at the end of the author we have the usernames, as you can see, James, Chloe, and multiple more. This endpoint author-sitemap.xml particularly contains emails and some personal information. So this is something you can look for if you are testing a WordPress application. A quick look. The impact here would be that the malicious people can collect the usernames disclosed and the admin user, and it can be used to perform further actions. Though the report is closed as informative despite having the high severity, but if this was the case in a pen test, it would actually be a good bug, not an informative bug. So this is again something you can look for. Moving on to the last report that is reported to Khan Academy. If you have a quick look at this report, it will not make much sense because it didn't make much sense to me either. So I'm going to explain you in a quick summary manner. Basically, the user uploaded a malicious SVG file to execute XSS payload. So this is the payload that gets executed when this SVG file is loaded. So if we look at the steps, it says consider the following example where this particular file is used in an article. We will override it by uploading the same JS but with a malicious SVG and JSON data because the hash is hash of JS. This particular server has files and these files can be overridden. So if you upload other SVG file and give it the same hash value, the existing file will be overridden with this file that contains different data now. And if that different file gets served to the people, the payload will get executed in their browser. So that's what basically it's doing. You can either upload a malicious SVG file or malicious JSON file. This both can happen in this case. And to automate this process, the user has created this form by appending SVG file that contains XSS payload, or by appending JSON file that contains XSS payload and submitting it to this subdomain using the post request. And by doing it multiple times, it gets cached in the CDN server, which is this one, cdn.kastatic.org. And because of the cache poisoning attack here, the payload is cached. So whenever someone tries to fetch the page, and if that page contains that malicious SVG file, the payload gets executed. As you can see, the user stays here, wait until cdn.kastatic.org updates its cache for caching the Graphy file. Okay, now we are done with the reports for today. I hope you enjoyed watching this video, and if you have any questions related to this video, you can ask it in the comments section. Thank you for watching, and I'll see you in the next one.